Greetings, grade 12. So today we are going to be looking at financial mathematics, finance, growth, and decay. So let's start. Right. So we are going to be looking at, first of all, here grade 10 and 11 summary. So in grade 10, you learned about the simple interest, when to apply it. So you must know that simple interest, we usually use it also when we are going to be using higher purchase. And compound interest, it can be used for growth and decay. Growth only, decay, that will be the straight line depreciation. And also compound formula is the magic of investment, remember. And then simple and straight line simple or straight line depreciation, remember the formula. It's like the simple interest. The only difference is that there is a negative sign inside there between one and the product of the interest rate and the period. And then compound and reducing balance depreciation. When you are calculating depreciation, so you use those two formulas. Okay, very important. And then the nominal and effective interest rates, the formula, you must know how to use those ones also, so you can revisit our grade 11 lessons. Moving on, so let's just look at calculating the period. So you see at grade 11, we're using exponential laws when we're calculating period, and it limited us on things where we could not use the exponential laws, so we got limited. But now we're going to be using logarithms to calculate the period. So calculating investment of a period, if it's not given, we are going to be using logarithms, and it makes it simpler. So if you are given the compound formula and you are asked to find the period of investment, so you have to use the logarithms. So you are going to solve for n, which is the period. You see that once you get to solving for n, you have to use logarithms. And then remember, on our lesson for laws of logarithms, which we introduced when we're doing exponential functions, so there we go, you use the logarithm. So n will be equals to log of a all over p to base 1 plus the interest rate. Okay, so please make sure you remember this. Let's just do an example to see how we apply the laws of logarithms to find the period of investments. Right, so Benji invests 5,000 rand into a savings account at a compound interest rate of 6% per annum, right? That is compounded yearly. After how long will there be 16,036 rands in the account? So here we write down our compound formula, because we know that it is compounded yearly. So we substitute our values. So we have the accumulated amount will be 16,036. The principal value is 5,000. Our interest rate per year is 6,000, and we don't know for how long will it take for the 5,000 to become 16,036. So we solve for n, which is the period of investment. So it's going to be divide both sides by 5,000, and then apply the laws of logarithm, right, which will be n log of, and then we divide both sides by log of 1 plus 6%. So we write them as fractions. You do not round off during calculations. Very important. The moment you round off, your answer is wrong. You only round off at the end. So our logarithm is going to be, yes, in the number of period. So it will take approximately 20 years for 5,000 to grow to an amount of 16,036 at an interest rate of 6% per year. So remember, you don't round off during calculations. You only round off at the end of the calculations. Okay, so this is approximately 20 years to 2 decimal places. Right, Moving on, let's look at what we are doing at grade 12. So at grade 12, we'll be looking at annuities. So annuities are the number of payments made at regular intervals, right, for a certain amount of time subject to an interest rate. So the interest rate, usually it's a compound interest rate, right? So we are going to be looking at the future value annuity, right, which is a regular payments made into an account, right? So their money will be used, it will accumulate to a certain amount at a specified end of a specified period. So we call that the future value. And then present value, this is regular amounts made to pay back a loan. So this present value annuity, you get a lump sum now, and then you have to pay back that money in fixed installments over a given period of time. It's also subject to interest at it compounded, which will be compounded. So you can see when we look about future value annuity, we are talking about getting a large sum of money in the future, and then present value, and then you have to pay small amounts of money for you to raise that particular amount. And then with present value annuity, we are looking at getting a large sum now. It can be buying a car on credit, a house on bond, or getting a large sum of money as a loan, and then you have to pay it back over a period of time. So that will be the present value annuity. So future value annuity, large sum of money to be raised at a particular date in the future. Present value annuity, it's a big sum of money now. Okay, so you need to pay attention to that. So let's look at the future value annuity. Just some hints, right? The formula first and where it is used. How do you know that I must use the future value annuity formula? So keywords, right? So when you hear that money is being paid into an investment account so that we have a specific amount in the future, you must know that you are going to use the future value annuity formula. And then if you talk about investment for a certain amount of money in the future, we will then use the future value investment formula, right? So depositing regular amounts in a savings account for a specified fixed big amount in the future, an investment or a sinking fund where you want to deposit of an asset and then replace it at a specified period in the future, then you use the future value amount. So here, any statement that has to do with a large sum to be used in the future for a specific purpose, right, or raising money by a certain date in the future, you use the future value annuity formula. So you will be paying fixed amounts of money in order to raise that money so that you can carry out whatever project it needs to be done in the future. Now let's look at the present value annuity formula. So the present value annuity formula, all these formulas, remember in our previous lesson we used some of series to come up with these formulas. So these are summation formulas. Are we together? So keywords or terms to pay attention to when deciding to use the present value formula are when you hear the words loan, right? Someone is buying on credit, someone is buying on loan. You are buying something on credit because you don't have the money now, and then you start paying until you pay off that money. Are we together? That amount. So a loan repayment, you know that you are going to use present value. Bond repayment, present value formula. Credit repayment, you buy a car on credit or an asset, whatever you are going to buy, but you don't have the money, you borrow. The moment you borrow, you know that whatever money you have, they are going to use the present value formula to calculate for you your installment, or you use the present value to calculate what annuity amount that person would be paying. So anything that has to do with getting a loan or buying assets on credit and you need to pay it back over a period of time and they are not paying cash. Let's look at some examples. Right. example number 1, right, is that 15,000 rand is invested into a fund at the beginning of every year for 5 years. Calculate total amount. So this will be calculate total amount in the fund if interest is 16% compounded yearly. So the keyword there is invested. So we know we're going to use the future value formula. So we write the future value formula and we substitute the installment. X is the installment, right? We put X there, and then the percentage is I, N is 5 years, right? So this is compounded yearly. That will be the amount. So therefore, after 5 years, if it is compounded yearly, right, then we are going to have 103,157 rands. Can you see that? Right. So that will be the total amount in the account. Let's look at another simple example. Right. So you must pay attention to the keywords that are being used, right, so that you know which formula to use. So here we've got Tapiwa takes a loan of right, he takes a loan, right, and he agrees. So let's remove that here. Right. So Tapiwa takes a loan. He agrees to pay 2,000 per month for 5 years, compound interest of 12% per year. How much was borrowed? There we go. So now we want to calculate how much money was borrowed. So that is the P. P there is the money or the loan borrowed. So we substitute the X, the installment, 1 minus, and then here you can see it's compounded per, so it's supposed to be per month. Sorry there. So 6% per year. Okay, everything is there for us. So they say that you can see the question is that she pays 2,000 per month. So which means we are going to calculate the interest rate per month. So that's why you see we have got 12% divided by 12. And then the time or the period of investment, we say 5, which is -5 in this case, multiplied by 12, because there are 12 months in a year. So there will be 60 months in 5 years. And then we divide by the interest rate. So we punch that into your calculator. You see that the total amount will be 89,910, which was borrowed, which he needs to pay back. Do you see that? So our P will be 89,910 rand 7 cents. So the borrowed amount is that amount. Okay. Moving on. Another example. They say example 3. Brandy buys a house on bond for 1,250,000. The bond is for 20 years at a 11% interest rate compounded monthly. All right. Question A. Calculate her monthly repayment. And then B. How much interest does she pay? Okay. So at the end of the 20 years. Okay, now A, so the clue there is bond. So the moment you hear about bond, you know that it's a loan, it's credit, borrowed money, right? So it's going to be present value interest. Then you substitute, remember it's per year, so per month, so you divide the interest rate per year divided by 12, even multiply the years by 12, and then you make X subject of the formula. So you use your algebra to manipulate. You multiply both sides by 11% divided by 12. Then you divide both sides by the bracket 1 minus, open bracket, 1 plus 11% divided by 12 to the power of -20 multiplied by 12. Right? And then you punch that into your calculator, you see that the installment will be 12,902 rands 35 cents per month for 20 years. And then B, the amount paid, the amount of interest paid, so we're answering B now, will be 3,000. Right, so total amount paid, we multiply 12,907.35 multiplied by 20 multiplied by 12, so multiplied by 60 months. How many months is that? That will be 240 months, right? And then you subtract that amount, you subtract the original amount from the paid amount, and then you see that there is a lot of interest which has to be paid, which is 1,847 rand 64 cents. Right, so the idea when you are given such a question is always to pay attention to the keywords. Which formula to use will be guided by the words used in the question. Remember, we said that if it is a present value formula, you look for bond, anything borrowed. Can you see that? If you borrow money, you have to work out with the present value money. If you are investing, you use future value because the lump sum of money is in the future. Right. Another example, Benji pays 1,500 per month. 1,500 per month, right? Into a savings account, paying 9.5% per annum compound interest. How long will the amount accumulate to 56,000 rand? So savings account, remember, the moment you are saving, which means you want it to be a certain amount in the future, so we use the future value annuity formula. So the future value accumulated amount is 56,000, installment or annuity is 1,500, then you substitute everything else, right? Remember, it is per month, that's why we don't know the years, but we know that it's going to be per month, so we multiply n multiplied by 12, so that will be the period, and then you solve for n. So you multiply both sides by the interest rate there, which is dividing on the right hand side. After that, you simplify. Remember, do not round off during calculations. The moment you round off, your answer will be wrong. Okay, you round off only at the end. And then now we use logarithms. It's going to be log of 583 all over 450 is equals to 12n log of, right? And then we use them as we simplify everything, then we divide both sides by 12. So here I'm going to use decimals. I hope you are following. Okay, it's still fractions. Let's use fractions, and then we divide by 12. All right, to punch that into a calculator, you get 2.73, which is approximately 3 years. So it will take approximately 3 years for the 1,500 deposits per month to reach an amount of 56,000 at an interest rate of 9.5% per annum. Okay, let's look at another example. Example number 5. Tindo buys a house for 800,000, right, on bond, right? Keyword right there. That's why I put it in red. And then pays 9,345 rands 52 cents per month for 15 years at 11.5% per year compound interest. Right. She decides to start paying or payment after 6 months. So this is a deferred payment kind of an example. So for the first 6 months, she's going to be paying nothing. So payments will start in the 7th month. Let's do a timeline so that we have an idea of what is happening here. So calculate a new installment of interest rate payment if interest is charged on the amount owed for the 6 months. So here maybe it's because, let's say, because of the COVID-19, the ongoing pandemic you see that a lot of people are having sort of leave to pay, but still that amount you will have to pay it, and interest will be charged. So if you have the money, once those things are given, you need to pay. Don't take advantage and think you are taking advantage. Actually, it will be a disadvantage to you. So let's do a timeline to see how this deferred payment will work out. So for the first 6 months, nothing is paid, and then payment would start from month 7 up until the 15th month. So which means this person is not applied for extension of the loan. They will still calculate the installment for the given period up until the 15th year, not 15 months, sorry, 15th year. Can you see? So it's from 7 year to the 15th year. So at the same interest rate, we presume that interest rates will not change. So in payments will start from 7 months up until the 7th year up until the 15th year. So it's going to be loan plus accumulated amount interest. Can you see that? So first of all, we have to calculate the interest rate for the 6 months. So we use the compound formula. After using the compound formula, you see that now the Benji will Tindo actually will be paying 847,116 rands 27 cents for the remaining 9 months. Is it 9 months? Yes, it's 9 months. Can you see that? So we are going to say, so because it's a bond, we're going to use the present value formula, right? And then we substitute the values in there. So we've made X subject of the formula so that we know we're going to be calculating the annuity or the payment. Right, so there we go. This person will be paying now 12,625 rands 13 cents per month. If they had started paying from month 1, they would have paid less. Can you see that? Moving on. Right, now you guys, you can do this question by yourselves. Try to answer that question. If you run into any problems, get in touch and we'll do the solution for you. Okay, enjoy.